should also have a calculator out. It's probably going to be the first test where your calculator is going to be pretty important. Try closing the other app or going at a lower quality. What you get? Ugh. I should trim out those parts next time I do this. Thanks, everybody. Okay, question 1. Okay, you want to measure the physical fitness of students at your school. Suggest several variables that you might use to measure fitness. Variables, what do you guys have? This is one of those questions where there really isn't a wrong answer unless your wrong answer is unrelated to the topic completely. So something that's related to physical fitness. And then we want to categorize that as quantitative or categorical. Let's start with Nicole. Body mass index. I don't know what that is. That sounds like a number.
Yeah.
So I think quantitative.
The percentage of fat.
Ooh. Percent of Kool-Aid, yeah.
So if it's broad, right, you could say like how fast they run 400 meters on the lap.
Sure, 400 meters. Do you want to go 400 or do you want to go shorter?
So you go like
400 sounds like a long...
It's one lap run on
400 meters? Okay. Let's do that then. A 400 meter run time? Yeah.
That would be quantitative.
400 meter running time. Quantitative. Good. That makes perfect sense. Let's get another. Let's go, Adam.
Muscle tone?
Muscle.
Or like muscle, what's like that term that they use? Or like that's it. Muscle mass?
Muscle tones and
Yeah, I'm sorry. I'm not very familiar with any of this.
It would be like the body fat.
Body fat.
Percentage of body fat.
No, like when you measure like how big
I think if you did muscle and stuff,
I don't know what that's actually.
it's based off the definition.
I'll put that in there. What the hell? Muscle tone. And I think we're gonna call that. Is that categorical?
Phosphorus is not.
You want to give me some categories just for fun?
Schwarzenegger.
Schwarzenegger, good. Schwarzenegger. Ryan Martin.
The definition of
It's Ryan Mark. M-A-R-K.
Oh, why did I put Martin? I'm sorry, I prematurely married people. What? Jake Stacy?
You gotta put the whole Jake Stacy, or it just doesn't work. There you go.
Like that?
No. S-T-A-C-Y.
Jake Stacy. Yeah. Gender. Okay. And I think that's categorical, right? I think we've had our fun here. I didn't even know Jake Stacy, and it's funny to me.
You will know it.
I will?
Yeah.
Oh, good.
We might like turn on people.
This is for I'll introduce you to
Okay.
Very nice.
Nice guy. Good. Does he like say his own name occasionally? No. Jake Stacy. Yeah.
Nobody calls him Jake. It's just either Stacy or it's Jake Stacy.
Yeah, that's the kind of name where you have to say both of your names, right?
Because they're both person.
Yeah. Jake Stacy. All right, number 2. I think this is going to be more serious, I think. hallux abductovalgus. Sounds disgusting. HAV is a deformation of the big toe that is not common in youth and often requires surgery. Doctors use x-rays to measure the angle of deformity in 38 consecutive patients under the age of 21 who came to a medical center for surgery to correct HAV. The angle is a measure of seriousness of deformity. Here is the data. Let's create a stem plot of the data. Does the data display positive or negative skew? Did you have a...
Right now, I just want to ask about the stem plot. So when you do it with like the stem would be like the ones place and the tens place, right?
I think you have it reversed, but yeah. Here's the thought for you. These numbers are not in order, right? Yeah. It'd be really nice if you could put them in order quickly. Yeah. So let's put them in order real quickly. Take out your calculator and throw those numbers into list 1. Yeah, I do.
We need this for the test. Mine is in my locker.
Okay, so to quickly clear all your lists, you can go second plus clear all lists. How do I what? Stat edit. Second plus clear all lists. Okay, that'll just clear up your workspace. Second plus.
Should we go over the calculator function?
Trying. As we do this. Okay, next we want to get to the lists. So the lists are in stat edit. So stat edit is number 1. And that'll take us to our lists. Great.
Edit the second one.
Hmm?
Just edit second one. I'll go down to
Alright, so to take a few minutes, you may want to have someone near you, like just read all of the numbers. So, you know, if we can form like groups right now, one person reads, everybody else kind of types. Reading and typing at the same time is, well, it takes a while. One person reads, the other person types. Yeah. Just put them in. We're going to order them in a minute.
It's great. This would have been helpful before the states.
Yeah.
Oh, Volvo. That's just like.
Okay, do we have all of them in our list? Okay, so this is like very basic with the calculator. Quit, go to the home screen. So at the home screen, I'm going to push clear a couple times just to make it look nice. And then I'm going to go to the list functions, which you obtain by pushing second stat. Go to operations. And sort A means sort ascending, which is what I think we want to do, right? Again, this is a home screen thing. You want to sort ascending. Which list? L1. Ooh, sorry, that was supposed to happen. Sort ascending L1. You can get L1 by doing second 1. Review. Sort ascending is under second stat ops. List 1, you can type that in by pushing second and then the number 1. Sort A is in second stat ops. It'd probably be a good idea right now if you notice that your calculator has tiny words in blue and green above each key. So when we push second stat, we're actually accessing list. Those are the list commands. All right, I'm going to push enter right now. Actually, it doesn't matter. Unless you have a TI-89. TI-89, it matters. Okay, so we should have list 1 sorted then, right? So we're going to push second. I'm sorry. We're going to push stat and then edit number 1 in order to look at that list. And look at that list. It's beautiful. Okay, so now it's going to be easier for us to make our stem plot, right? All right, so the first stem is going to be zeros in the 10 place. What the heck just happened? No. No. A 0 in the tens place. And then there's nothing there, right? There's no number less than 10. And then a 1 in the tens place. I'm putting it there just for reference. So we have 3, 4, 6, 6, 7, 8, 8. 3, 4, 6, 6, 7, 8, 8. Isn't that nice? It's already in order for you, too. The next stem is the 20s place. 20. And I think this is going to be a lot of one. So 0, 0, 0, 2, 0, 0, 0, 1. We have 1, 1, 1, 2, 3, 1, 1, 1, 2, 3.
Then you have 4
4
5s.
5s. 4 5s.
4 6s.
4 6s, 2 8s, and 3 8s. 1 2 3 4 1 2 3. Okay. Let's keep on going with that 3. 0 0 0 1 2 2 2 0 0 1 2 2 2. 4 8 8. Great. There's nothing in the 40s. In the 50s, we have just 1 0, right? There we go. Good, that's our stem plot. Alternatively, oh, sorry, we need to leave a key here, right? So the stem is the 10 place, right? So in other words, this 2 right here, it means 20. So 2 times 10 is 20. And the leaf is in the 1's place. So you need to leave the place value for stems and leaves.
Is it wrong to put commas between all the numbers?
No. Alternatively, you could use a split stem method. For example, when we do the 1s, we're going to start with all of the ones that are between 0 and 4. So just 3 and 4. And then we'll do another stem for the 1s for all the numbers from 5 through 9. All the digits from 5 through 9. So that's 6, 6, 7, 8, 8. If the list of leaves get too long, then it might be necessary to do it this way. Okay, the 2s, all the leaves that are less than 5. Two, all the leaves that are 5 or greater. Again, this is split stem method. Not always necessary, but it helps you look at the data if those stems are getting too long. Yeah, you can kind of see it on both of them. I don't know, which one do you think it looks better? The second one seems to have more detail, doesn't it? Also, did you start to notice that the stem plot is basically a histogram turned sideways? Yeah.
I have a question. If you have numbers that are in hundreds, can you make it so that it's like 120 is one stem, and then you put the 1 space in the numbers?
You could, but I think that's going to be really inefficient. Okay.
So do it like 1.
You generally want to take the highest place value and use that as your stem. Generally. Okay? And number 3. Oh, A. Make a stem plot. Does this display positive or negative skew? Positive skew or negative skew?
Wait, is that left or right? What's the negative?
Positive skew. That's the term. I'm changing this because that's the terms that your textbook is using. Positive skew means that you have a lot of numbers that are low, not a lot of numbers that are high.
So when would it be negative?
Negative skew would be if you have a lot of numbers that are high, not a lot of numbers that are low.
So same thing as right and left.
Same thing as right and left. Hey, this fan works great.
My room next door is freezing.
Yeah.
Not that I have room for all these people.
Well, it's a big house.
I do have wooden chairs. They're by the front.
I don't know if there's anything I have to do.
Yeah, it's okay in the morning. It's just the afternoon. This afternoon, you'll see how horrible this classroom is when only one air conditioner is working at 50% capacity.
Or what's on it?
That air conditioner is dead. That air conditioner is barely working. So when we get here this afternoon, it's going to suck in this room.
Yay! Something's look forward
I have to borrow a fan from somebody. Not for me, for you guys. I have a fan. How you doing? Okay, part B. Use class widths of 5 to create a frequency, relative frequency, and cumulative frequency table. Okay, so let's make our table.
Where's the mean by five?
So the classes that we're going to use. So you wanted frequency, relative frequency, and cumulative relative frequency. Really? She was just here. Great. So the first class is from 0 to less than 5, right? Not including 5. So 0 to all the numbers that are less, no, not 0. 10 to all the numbers that are less than 15. The class width refers to how big is this interval. The numbers that I'm describing here from 0 to 15, I'm sorry, from 10 to 15 is 5 units long, right?
Yeah.
So the class width here is 5. So this first class is called 10 to less than 15. This class width is 5.
You can do 0 to 5.
There are no 0 to 5s.
Oh, well, yeah.
Yeah. I mean, we could easily just go 0 to 5, but we're just going to get a lot of nothings. Okay, great. How many are there from 10 to 15? 2. Good. We're going to leave the rest of that blank. Next one is 15 all the way to all the numbers that are less than 20. How many is that? 1, 2, 3, 4. Looks like there are 5 of them, right? From 15, including 15, to all the numbers that are less than 20. Did I say 5 just now? Okay. 20, including 20, and all the numbers that are less than 25. That's 5, 6, 7, 8, 9. So we have 9 here. Next class is from 25 to all the numbers that are less than 30. That's 3, 4, 5, 6, 7. That's 8 of them, right? No?
11.
Between 25 and 30?
Yeah.
Oh, I'm looking at the wrong one. Sorry. You're right. All the numbers including 30 to less than 35. That should be 8. From 35 to all the numbers that are less than 40. 2. From 40 to all the numbers that are less than 45. From 45 to all the numbers that are less than 50. And then 50. And then all the numbers that are less than 55. Just that one. Hi. Justin, Caesar, Leslie, Fanny, Leslie, and Simone. Caesar's not here. Okay.
Do you want to?
All right. So, how many measurements did we make? 30. How much? 38. Okay. So now we have to divide all of these by 38, right? Great. This is where the calculator is going to come in handy again, right? There are 38. It tells you here that there are 38. Okay. All right, I'm going to clear off list 1 and start over again. Don't need those numbers anymore.
Can you just put on list 2?
Yeah, you could put it in list 2 also. So we got 2, 5, 9, 11. Did I do that right? Okay. That represents all of my classes here. And I want to take all of those frequencies and I want to take them in list 1. We did this already, right? And we're going to divide by 38. So that's 5, 13, 24, 29. Everyone see that? 5%, 13%, 24% rounded, 29% rounded, 21. 5, 13, 24, 29. Whoa, what did I just do? 13.
First you have to highlight the list.
21, 5. 0.03. Everyone got it? Remember, you're going to have to do this for yourself tomorrow, so learn how to do it now. Take notes. You need to borrow one. Do you need one? Remember, it's still possible for you just to take everything and divide by 38 by hand. Yeah, it'll just take a little bit longer. Okay, now we have a choice. We could either add these by hand or we can have our calculator do them. I think I'll just add it myself. We start with 5%. We're going to add to that 13%. We're going to add to that 24%. We're going to add to that 29, 60, 71. We're going to add to that 21. We're going to add to that 5%. We're going to add to that 0%. We're going to add to that 0%. And then we're going to add to that 3%.
I have a question. You know how sometimes since you're rounding in the relative frequency, it could kind of be, instead of 1 at the end, it could be more than that?
Yeah.
On the test, you want to just put 1 because that's like
No.
the logic. No, you want to
No, yeah. It's a really good question. It is possible for this not to add up to 1. It is possible to add up to 1.01. And that would occur if you have a lot of rounding error. No, it's not wrong. Okay, we expect there to be some kind of rounding error, so we'll look out for it. Lastly, here I think part C, we're supposed to create our histogram and our cumulative frequency plot. I'm not quite sure we have enough time to do all of that, so we will finish that probably in class tomorrow. Okay, either that or after school. Actually, let's do the histogram now. My bad. Let's do the histogram now. Okay, so we want to start off with axes. Okay, and for the plots, this is very important for you. Please listen. Last year, the #1 problem with everyone's histogram is they did not put a number line across the bottom. This is not a bar graph. This is a histogram. Histogram requires a number line across the horizontal axis. So we're going to start off with a question. How wide are my class widths? By 5, right? So you know what we need to count by? 5s. Good. 0. 5. 10. 15. 20. 25, 30, 35, 40, 45, 50, 55. My tallest bar is going to be 11.
Didn't it say for a cumulative?
Okay. Questions on setting that up? if your class width is 6, you're going to count by 6s. Okay, so the first bar goes between 10 and 15, and it is 2 units tall. So between 10 and 15, 2 units tall. It does touch the 15. I just have bad aim. The next one's between 20 and 25. No, between 15 and 20, and that is 5 units tall. Between 15 and 20, 5 units tall. Yes, the bars are actually adjacent to each other. They are touching. Remember, number line first, then do the bars. (20 to 25), that bar is 9 units tall. (25 to 30), I think that bar is 11 units tall. (30 to 35), how tall is that bar? 2?
Sorry.
8?
And then it's
Sharon. Eight, and then 2 again. Then 0, 0, 1, right? Great. And that's a great histogram. Nothing wrong with that. Are between the class widths, yeah. The bars are adjacent. They go from class width to class width. Or left boundary of the class to the right boundary of the class. I think that's where we're going to have to pause it today.